Okay, so to change this from DMS, that's what this is called, degrees, and then what's the M? Minutes, and then what's the S? Seconds. To a decimal, it'd be 8 point something. And the point something comes from this. That's 4 minutes, which is 4 out of 60 because there's 60 minutes in, yes, I know it's in an hour, but this is in a degree. The degree is kind of like the hour. All right, anyway. And then this 12 is 12 over 3600. But there's a really cool way to do this with a calculator. I wanted to wait to show you until today. So would you grab your calculator? And I want you to show you how to put this into the calculator to get the decimal and vice versa. So these are angles. Remember, it's an 8-degree angle. It's like this. At 0, that's like about an 8-degree angle. It's a really small angle. All right? Or you could have it from here and say like, okay, starts there. That's called the initial side, and the terminal side is here, and that's an 8-degree angle. But it's a little more than 8 degrees, so they got this other junk. So look on your calculator for the angle menu. It's right above apps. Type in an 8 first, and then go to that menu. I'll show you exactly what to type here. If you go type in an 8 first. Come on, calculator. Quit. Clear. Okay. Type in an 8, then go to the angle. It's right above apps. Need a calculator. They're in this drawer here. There. Then, see that little degree sign? Hit enter. Now you got 8 degrees. Next part, 4 minutes. You go 4, then you go back to that same menu. Second, it's above apps. There we go. And it's the next one down. But notice there's no seconds on here. I'm going to be able to do minutes, but the seconds one, somebody's got to tell TI this is really stupid. They put the degrees and the minutes, but then they don't do the seconds there. The seconds is in a totally different place. The seconds is down above the plus sign. You have to hit the alpha key. So you go alpha, and it's above the plus sign. So I got to, first of all, I got to type the number. I want the number, get off alpha. Not second. Okay, I want to type in 12 seconds. So I go 12, and now it's above the plus, so I go alpha plus. There, 12 seconds. I hit enter, and bingo, bango, bongo, I've got my decimal. 8.07. Okay? So, just check yourself here to see if you really get this by please put in 9 degrees, 9 minutes, and 9 seconds, and see what 999 gets you. Didn't work too well for the candidate, his 999 plan. You know what I'm talking about? Herman Cain. He was a force for a while. Then he had all his accusations come out, like 12 people. And so he finally was like, okay, I'm out of here. I don't blame him. He had so many people accusing him that it was going to be really tough to overcome that. All right, so if you type that incorrectly and you hit enter, it gives you a decimal. Would you tell me what it gave you? Good. So which one's better? Well, it depends what you want. They're both the same thing. Just one's in DMS form, and this is in decimal form. It's sort of like saying what's better, 9.25 or 9 1/4. They mean the same thing. Okay? Just depends on what you want. All right. Next thing. Can I start with the decimal and get it to this form? Like what decimal would give me this? Well, I can start with a decimal of, let's say, 8.27 degrees, and I can figure out what that is in minutes and seconds. Type it in, 8.27. Just type in 8.27. And now go to the same menu. Just a second. I got to catch up. 8.27. And then I go to above the apps key angle and take a wild guess which one I'm going to hit. Number 4, which is 2 DMS. Right there. Enter. And one more time, enter. There it is. 8 minutes, 16 seconds, 12. Sorry, 8 8 degrees, 16 minutes, 12 seconds. All right? So this is just a know where it is on your calculator thing, and that part will be really easy. Okay? There are questions in the test about it, so know how to do it. All right. Next. Yes. Yes. Otherwise, you'd have to be dividing nasty things divided by 60 and divided by 3600. You're not going to be using that in your head. All right. How about changing degrees into radians? Do you remember I said a radian's about 60 degrees or so? Do you get that this would be a little bit more than 1 radian then? Well, exactly how many radians is it? It's 1 point something. Well, you use the factor. You either multiply it by this or you multiply it by this. Well, which one makes sense? I put them in here and I say, well, let's say I think it's 180 over pi. Do you get that nothing would cancel here? And you'd have degrees, which is actually degrees squared in your answer, which is not good. Okay, so that's not the way I should do it then. So I should go put the 180 on the bottom. And I should put the pi on top. And now do you get that these degrees will cancel? One more thing that's important to understand is that we put this little word radian in there to make you understand what you're getting. But did you know that radians don't have any units? It's kind of weird. It's like they're not a unit like inches or degrees. Radians are one of the only things that you deal with that is just a pure number. And I'll show you why that matters in a little bit. But for right now, just understand that your answer's in radians, but radians are not a unit. It's technically just a ratio of 2 numbers. All right. So like speed is in miles per hour or feet per second or whatever. You've got to know what it's in or to make sense. But radians, they're just a number. Like 4. Doesn't have any units. Okay, anyway, so to multiply this out, please take your calculator, type in 67.05, find the pi key and say times pi, and then divide by 180, and you'll have your final answer. Miss N, can you tell me what you got? 1.17 approximately. Raise your hand if you got that too. Okay, good. Then remember what I was saying, this is a little more than 1 radian because radians are like about 57 degrees, so 67 degrees is, yeah, it makes sense it's a little more than 1 radian. Would you have to write radian? Technically, no. But you need to understand whether you're in degrees or not. The degrees did cancel, so they're gone. So it's just radians. All right. So you should be able to handle any question like this. If they say 2.43 degrees, you should be able to change it to radians. Or 4.9 radians, change it into degrees. Do you get how to do that now? You're either multiplying by pi over 180 or 180 over pi. All right, if you really understand this, figure out the answer to A, figure out the answer to B. It'll just take you 2 seconds. Get used to that, where that pi button is. You're going to use it a lot. Don't freak out that the first one is a very small number, because think about it, it's only 2 degrees. It's way less than 1 radian, right? Because a radian's about 60 degrees, so. Okay, MM, would you tell me the first one? Not done yet? I'll come back to you. I'll come back to you on the second one then. All right, I'm going back to M, Mr. F. What would you tell me what your answer is on A? 0424. Can anybody verify that one? Okay, good. Then, that's in watts. It's really nothing, but you could say radians, couldn't you? All right. Now, this other one, 4.9 radians. That can change to, wait, that's a lot of degrees, right? Isn't each radian about 60 degrees? So 6 times 4 is like 240 degrees-ish or something like that? Yeah, it's a lot. Yes? Can anybody verify that number? Okay, good. All right. So we can change back and forth by just multiplying by either pi over 180 or 180 over pi. You want to pick the one, it makes things cancel. All right, next. Circle stuff. You are expected, and therefore I'm telling you once, and now you got to know forever, including when you have the test. These formulas are things you're expected to know, which is like area is pi r squared, and c equals pi d. And no, on the test, if you come up to me and say, can you remind me that circumference formula? No, I won't. Okay, so you got to know this one. Memorize it. You've learned this in 7th grade. Circles are big, especially in trig, because there's a lot of circle trig. So you need to know these. All right? Okay. Next thing. Trig basics. SOHCAHTOA sine is, what's O and H? Opposite, yes, over hypotenuse. And the cosine is AH, which is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so this one I've got set up right. Sine is opposite over hypotenuse. And I've put a degree in there of 30. All right. Here is a typical way you would use a sine function. Let's say I was going to figure out in this triangle here, if that angle is 30, and I wanted to know if I knew its opposite or its hypotenuse. Let's say I knew this was going to have to be, say I was building a ramp for Evel Knievel's kid, who I think is Bobby Knievel. Anyway, and he like jumps over flaming things, or the famous one that Evel Knievel did was jumped over the Grand Canyon with his built up the ramp and then got on his motorcycle and going to jump over that thing. Obviously not at its widest point. That is pretty much impossible. But anyway, so let's say he knows, he's done his calculations, he wants the ramp to be 80 feet this way. Okay, so that's the hypotenuse. And he knows he wants that to be a 30-degree angle. He wants you to figure out, that's the hypotenuse. What could I figure out from this? The opposite side. Because see, I have opposite and hypotenuse. So I can figure out that side right there. Like how high does the ramp need to be off the ground? Okay, you're going to use your calculator. And we'll set this up together here. Do you get how I have sine of 30? And that's something you can do on a calculator. Is equal to opposite, which I don't know, so what do I put for that? X over the hypotenuse, which is 80. And so I just have to know what this is, and it'll be really easy to solve this for x. Right? What is sine of 30? Your calculator will tell you. 0.5. Degrees. You want it in degrees, because this was in degrees. 30 radians would be that angle would not be 30 radians, right? That would be a massive angle. Okay. Anyway, so this was 0.5. And so can you solve that? I hope so. You multiply by 80 on both sides, and you end up with 40. And now, does anybody remember one of those rules from trig that could have told you that that was 40 in the first place? Remember that? Because it's in a 30, 60, 90 triangle. And if you're in a 30, 60, 90, this side and this side, one of them's twice as big as the other one. So it could have known that just from that. All right, so that's another thing that you need to just kind of remember is these triangles. If you do not have these memorized, write them down now and memorize them. I drew that really badly. I'm going to try to make it actually about 30 degrees because it makes more sense when they look like the right lengths. Say that's 30, that's 60, that's 90. This side is x. This side is what? 2x. And this side would be x square roots of not 2. So common to make that mistake. Because the other one has the 2 in it. And that's the 45, 45, 90. And that's x, and in other words, these two are the same. And this one is what? X square roots of 2, yes. Okay, got to know those. That's why I'm going over them 2 days in a row. All right, moving on. Sectors and arc length. This is, let me see if I can swing this around. That is a sector. That whole thing in there. This is an arc. I really wish this formula had an A in it for arc, but it doesn't. This is the formula. In fact, I'm just going to get rid of this one. Don't use that one. Use this one. S-O-R, SOR. And it's technically not an O. You know what that Greek letter is? Not an omega, good guess. It's a theta. Theta. Anyway, S equals theta R doesn't have as good a ring to it as SOAR. We're just going to be using this formula a lot, so I have a name for it. Okay? It's kind of like an O. All right, so here's what you do. This, it seems like S for sector, but it's actually, that's the arc length. So why don't you label right now, write down the formula, and this is the arc will be that many radians times the radius. So like if I need to know how long that blue line is, do you get that it depends how big an angle I opened up there? You know what I mean? Like this angle I made, that makes a difference on how long the arc is, right? So of course that angle's important. That's this part. That's the angle. Notice it has to be in radians. And then how long the radius is, like this distance right here. That makes sense that that would make a difference, because if it's a big circle, the arcs are going to be bigger. All right, so all you really got to do in this kind of a problem is pretty simple. Is if they give you this is like 8, then I stick it into the formula, and I got to know how many degrees it is too. And I'll tell you that. Let's say, would you guys agree that looks like about a 45-degree angle? Okay, so let's say it's a 45 degrees. But can I put degrees into this? No. Remember, it's got to be in radians. Because if I use degrees, watch what would happen. My answer would be 45 degrees. Oops, can't write. 45 degrees times 8, and let's say this is inches. Do you get my answer would be in degree inches? And that doesn't make any sense. I want this in inches. So do you get why this can't be degrees here, and it has to be something that doesn't really have units? Remember I was saying before that radians don't really have units? Because otherwise it would be 8 inches times some other thing. They'd be inch things. Inch radians. Wouldn't make sense. So radians don't have units. So why can't I just put a 45 there? Because 45 is in degrees. So in the bottom line answer is this is 8. This, I figure out what 45 degrees is in radians, and you guys know how to change that, right? I just taught you 2 seconds ago. Try it. Multiply by either pi over 180 or 180 over pi, whichever one you're supposed to, and then multiply it by 8, and then you'll be able to tell, does my answer make sense? If your answer is like 23 for this distance right here, then I'm going to say you didn't think about it. That can't be 23. If that answer came out to like 1, it doesn't make sense. All right, so first of all, guy in the back in the blue, I know your name, but I don't say him on the videos. Tell me what to multiply by. Pi over 180 or 180 over pi? Why? Correct. Okay, now you do 45 pi divided by 180. Did you get a decimal for that? 0.78. And I'm going to put radians, even though it's not really a unit, but it'll remind me what it is. This is a radian calculation. All right, so I figured out it's 0.78. I times that by 8. It should be about 60-something. No, what is it? 6.28. Thank you. Now, just think for a second. Does it look like that should be about 6 if the radius is about 8? Does it make sense? Does to me. If I, remember curved lines, if you straighten them out, they look a little different, but if I were to take that red line and like lay it out flat and go like this, if the total was 8 and that's like about 6.2, that makes sense, right? Okay. All right, so this formula, super important. SOAR. Some things that you'll need to know about it. What if they give me this and this? Well, I just make sure it's in radians and I multiply them together and I'm done. But what if they give me this? Can I figure out this? Yes, I can. I'll give you an example. Let's say that I knew that this was 8 inches long and that this was 7 inches long. Could you figure out how many degrees it is? Absolutely. What would I stick where? Where does the 8 go, the S or the R? It goes there. So 8 goes here. And where does the R go? Well, 7 goes under the R. Duh, sorry. I said it funny, but there we go. And do you see how I could solve for theta? Just divide by 7 on both sides. It'd be 8/7, which is like a little more than 1. And does it look like it'd be a little more than 1 radian? Because 1 radian's about 60 degrees, so yeah, a little bit, that makes sense. Well, it depends. If they ask for radians, you just give them the 1 point whatever, 1 1/7 radians. If they want it in degrees, you know how to change it to degrees. Multiply by either pi over 180 or 180 over pi. All right. And you get, again, that radians aren't going to have any units because this is 8 inches and this is 7 inches. And when I divide 8 inches divided by the 7 inches, I'll end up with the units cancel and there's no radians. There's no units. So radians don't have units, which is a little weird thing to get your head around. All right. So you got a lot of time to work now. A little less than half an hour. And your assignment is right there. 356, 25 through 41. That's again page 356. Problems 25 through 41. We'll grade all of that tomorrow. Okay, I got to ask one last question. If you were to go from degrees to radians, let's say it was 25 degrees and I want to go to radians, which one do you use is what you're asking me. I want to show you so that I don't have to have you memorize it. You just have to know it's 180 and pi. And you think about where to put them. If I put the 180 here, do you get how that won't work out so good? Because they won't cancel. If I put the 180 here, now they'll cancel. So I'm not going to like make you memorize it a certain way. I just want you to think it's a 180 and a pi, and you put them where that makes sense. Now the degrees have canceled. Now my answer would be 25 pi over 180, which, yes, you usually use a calculator to figure out. Okay? And that's radians.